Well, let's see. We're going to be talking about reducing fractions in the next problem set. In problem set 26, you're kind of laying the foundation for how to reduce fractions, okay? Here's the idea though. Remember you talked about the definition of multiplication? When you multiply these two fractions together, let's see, you multiply straight across. And then, remember, if you have a negative on the bottom, move the negative up to the top. For this one, you're going to want to change to improper fractions first. And you get, when you multiply straight across, you get negative 25 over 6. Okay, for reasons you'll learn in just a minute, the concept of factoring is going to come into play here heavily when we reduce fractions. Remember how to factor? Remember what factoring means? Remember the definition of factoring? It's really important. If you understand the definitions of what these things mean, it really sticks a lot better and deepens your understanding. To factor means to write as a product. And so when you take 84 and you factor completely into primes, that's what it means to factor completely. You should get 42 times 2, which is the same as 6 times 7 times 2, and then your final answer would be 3 times 2 times 7 times 2. And of course you can write those factors in any order. But when you factor 12xy plus 8x, you don't use primes. What do you use here to factor this? You use the distributive law, right? And you're looking for the greatest common factor. You might want to go back to problem set 14 if you're feeling rusty on that, but you look for the greatest common factor. If there's more than one term, you got to use the distributive law. So in other words, you've learned two very different ways to factor in this class. And when you get to Math 80, you'll learn about 8 ways to factor. But remember, when you factor an expression, you're factoring it, you're writing as a product. That's what it means. Okay? Now, on these two, go ahead, hit the pause button. See if you can factor these completely. On the first one, did you get negative 1 times, let's see, on the first one, did you get negative 1? And then you should have 3 factors of 3, a factor of 2, and an a times a b. On this one, this was kind of sneaky. You don't use the distributive law because these are like terms. You can combine them. So always look to do that. And so you don't have to use the distributive law on this. On f, you just write it as primes: 2 times 2 times 5 times x times y. Okay, so here's the idea. The definition of multiplication is usually written from right to left, but if you write it in the other order, it says that when you have a fraction that's in product form, right, it's factored. This is factored on the top, factored on the bottom. You can break it up into 2 fractions and write it as a multiplication problem. That concept is how we're going to reduce fractions. Let's just practice taking a fraction and writing as the product of 2 fractions. You got to find two fractions so that on the top it multiplies to give 8, and on the bottom it multiplies to give 10. So one that would work would be 1/2 times 8/5. You see? There's other ways to do it too. If the first fraction was 4 over 2, the other one, in order to get 8/10, wouldn't you have to have a 2 here and a 5 here? So there's lots of ways to do it. How about this one? Can you think of 2 fractions that multiply together to give this? If you first move the negative up to the top, then the product of the numerators has to be negative 5x, and the product of the denominators has to be 6y. There's lots of ways to do it, aren't there? Here's one. On your homework, your answer might look different than the back of the book because you may have chosen different ways to break it up. How about this one? If you wanted to write this as the product of 2 fractions, you first write it as a improper fraction, right? And then here's one way, 9 over 2 times 1/2, right? As long as the product of the bottoms is 4 and the tops is 9, you're fine. This one, 24 over 42, well, any 2 fractions so that the numerator multiplies together to give 24 and the bottom multiplies together to give 42, that would work. Now it turns out, so this one would be okay. This one is really important because, see this second fraction is 6 over 6? What does 6 over 6 equal? 6 over 6 equals 1. So whenever you multiply a fraction times 1, it's just itself, right? So this fraction is actually equal to 4 over 7. And that's how we're going to do the reducing in the next problem set. But let's, for now, just practice writing things as the product of 2 fractions where one of the fraction equals 1, like what we're doing here. Let's try to see if we can do that. There's a hint. Whenever, if you want to try to do that, what you should do is you should factor the numerator and denominator completely. It makes it a lot easier. So if you wanted to write this as the product of two fractions, where one of them equals 1, you first factor the top and bottom, and then you can peel off the common factors to form your 1, you see? The top is 2 times 2 times 2, which is 8. The bottom is 2 times 5, which is 10. So take a factor of 2 and a factor of 2, call that your 1, and the other fraction is everything that's left, you see? You take all the common factors. In this one, there's only one common factor, but if there was more than one factor, you'd use that as your 1 also. So it becomes 2 over 2 times 4/5. You see? That's how it works. For this one, we're trying to write it as the product of two fractions where one of them equals 1. Let's move that negative up on top. And then what we're going to do is factor the top and bottom completely. So it's time to get good at this. If you're not already, get really good at factoring. 56 is 8 times 7, 8 is 2 times 2 times 2, so when all the dust settles, you factor it. Now what are you going to form your 1? Well, what's going to be your factor of 1? Well, there's a 2 here and a 2 here, and there's actually 3 2's on the top and 3 2's on the bottom, which equals 8 over 8. That's going to be your 1. Now what's the other fraction? Well, what do you have left if you take away the 3 factors of 2? You'll have a negative 7 on the top and a 3 on the bottom. So this is what they want you to do. A couple more, then I'll give you some to try. How about that? This one, negative 5 over negative 3, you factor the top and bottom, and see the 1, it turns out, is going to be the negative 1's.
You get negative 1 divided by negative 1 times 5/3. So this is your factor of 1.
Interesting. Last one here, and then I'll give you some to try. This one, you factor the top and bottom like this. Now the common factors are going to be used for your factor of 1. So what are the common factors? Well, there's an x, and I think there's two 2's. Well, the two 2's are 4, so you can take two 2's and an x out of the top and bottom, so 4x over 4x, and what's left? On top you have negative 3, on the bottom you have y. So this is what they want you to do. So now, go ahead, take these fractions, write them as the product of two fractions where one of them equals 1, and my hint is to factor the top and bottom completely, and then use all the common factors to form the 1. Hit the pause button. We'll go over these in just a second. Okay, so again, what we're trying to do is we're trying to write this as the product of two fractions, where one of them equals 1. So if you factor the top and bottom, now, you know, when you factor these numbers, you'll get really good at it because the numbers are the same numbers over and over again. You're not going to be asked to factor like 648 or anything like that. So you'll get really good at it. You probably be good enough at it where you can just go right to the answer. You might not have to go to 4 times 5. You may be able to go right to here eventually. Anyway, what's going to be the common factors that form a 1? I think I see a 5. That's about it. So the 5 over 5 gets pulled off, right? And the other fraction, what's left on the top if you take out a factor of 5? It'd be the 2 times 2, which is 4, and the 3 times 3, which is 9. So this is what we're after here. Next section, next problem set, we're going to go the next step, and we're going to take away that factor of 5 over 5, and then our answer is just going to be 4/9. We'll do that next one, though. But this is leading up to that. And eventually we're going to start to abbreviate a little bit too, but it's important to learn all the steps when you start out, isn't it? So to factor this, you get negative 1 times 4 times 12, or over 6 times 10. I did an intermediate step here if you want, that's good. But when you break it down to primes, eventually you get down to here. Look for those common factors. It looks like there's 2 2's and a 3 in common, right? So if you take away the 2 2's and a 3, I think you have a 5 left on the bottom, and be careful here, I think you have what, 2 2's and a 3, you still have 2 more 2's and a negative 1, so you have a negative 4/5 over here. This one isn't too bad. When you factor and you pull off that negative 1, this is why it's important to pull off those factors of negative 1, you see that your common factors is going to be a negative 1 times x, so make that your 1. What's left is 4/9. This last one, this one's kind of a lot. Factor it. Like I said, you might not be able to go right from here to here, but when you finish your factoring, this is where you should end up. Let's see. What's going to be the 1? There's a w, and I think there's 2 factors of 3, so it'd be 9. 9w over 9w. What's left on the bottom? If you take away the 9 and the w, don't you have a 5? Should be a 5y, shouldn't it, on the bottom? 5y. Yeah, there we go. 5y on the bottom. On top, when you take away the 2 factors of 3, you still have a -4. So it'll be -4 over 5y. There's your answer. All right, so next time we'll actually do the reducing. See you later. Bye.